Hello everyone. In last video we discussed about the self inductance, then definition of self inductance, what are the SI units, and how to measure the self inductance, how the EMF is increases and decreases just by opening and closing of the key. So in this session we are discussing about the self-inductance of a long solenoid. So basically we know that the long solenoid we are representing, and their magnetic field we are representing representing their magnetic field B is equal to mu naught N into I. So magnetic field at the center of the solenoid is always maximum, and at both the ends of the solenoid magnetic field is exactly half of mu naught N into I. So here you can consider the solenoid of length L and having a cross section area A, and the number of turns per unit length is N. Suppose that current I is passing through the solenoid, and then magnetic field inside the solenoid is nothing but here B is equal to mu naught N into I. In case of long solenoid, the length is very large. This length L is large as compared to the radius of the loop. Okay, so here we can say that the magnetic flux passing through magnetic flux passing through each turn of the solenoid is nothing but the magnetic field into the area of each turn, so B into the area of this circular loop. So here B into A. So we know that inside the solenoid the magnetic field is mu naught N into I. Substitute the value over here, mu naught N into I into this area is A. So here magnetic flux phi is nothing but magnetic flux linked with the one turn 2 into total number of turns. So here we can write total number of turns in the solenoid is nothing but N into L. N into the total length is L. So we can write phi is equal to mu naught N into I into A, and number of turns are nothing but N into L. Okay, so here this N and this N is remain same, so we can write mu naught N square I A into L. So this is nothing but a flux, and here L is the self inductance of the solenoid, and in the previous class we learned that the self inductance is directly proportional to the flux, and we can write phi is equal to L into I. Current is directly proportional to the flux and phi is equal to L into I. So we know that here phi is nothing but this value. You can substitute here mu naught N square I A L is equal to L into I. The current will remain same, and I'll get a equation L is equal to mu naught N square A into L. So this is nothing but self induction in the long solenoid. Okay, very important derivation. Numericals also comes from this point. So very important derivation from the exam point of view. Thank you.